Another classic interview question is to design a data structure that follows the constraints of a least recently used cache, or in other words, build an LRU cache. Here on the screen, I have the exact requirements that you might find on a site like LeetCode. The general idea is that you want a data structure that works like an object or map where you can retrieve an item, but it has a fixed length that automatically gets rid of the oldest item. The LRU cache is used frequently in the real world. For example, you might have an app that returns recipes, and so you put the most popular recipes in a cache. The cache is small and fast and lives in memory, while your main database is big and slow and lives on the disk. What I'd recommend you do now is read the problem carefully and then try to implement it on your own. Pause the video and come back, because now I'm going to talk about how I would solve it. In this problem, we're asked to create a custom data structure. There are many possible ways we could go about it, but in this case, we'll need to manage state and functionality, which is a perfect fit for our own custom class. Let's go ahead and give it a name of LRU. Now, before we get any further, I want to point out that JavaScript classes are just syntactic sugar for prototypal inheritance and functions. Instead of using a class here, we could actually just define a function and then use its prototype property to add a variety of different methods to it. This works as well, but in my opinion, it results in code that's just harder to read and understand. Inside the class, we'll first define a constructor, which is like a function that gets called when a new object is first initialized. We'll give it an argument of capacity, which is a number that defines how long the cache can get, like it might store a maximum of 10 items. Now we use the this keyword to set it as a property on the object. Most importantly though, we're going to use the built-in map in JavaScript and set that as the cache property on this object. The reason we're using a map here and not just a plain JavaScript object is because when you insert a key value pair into a map, it maintains the order of them. That's really important because we'll need to find the last item that was inserted and evict it when the LRU reaches capacity. These two properties represent the state of our object. Now we need to define some methods or functions to interact with them. First, we'll define getItem to retrieve an item from the cache based on its key. This is really simple because the map has a built-in method called get that takes a key and returns the item. But here's where things get interesting. If the item already exists in the cache, we'll want to delete it and reset it on the map. The reason we do this is to update the insertion order, because remember, we always want the most recently accessed item in the front. Now, when the LRU reaches capacity, we'll need to find the oldest item and remove it from the cache. In order to do that, I'm setting up a getter with the get keyword followed by a function called oldest item. Get is not really necessary here, but what it allows you to do is call it as a property instead of a function with parentheses. Now, in the body of this function, we'll return the cache keys next value. Keys is just a method on the JavaScript map that returns all of the keys, and then next we'll grab the first one, which will also be the oldest one. Now that we can get the oldest item, let's implement the putItem method, which will add a new element to the cache. It takes a key and value as inputs. Then the first thing we'll do inside of it is check to see if the cache already has that key, in which case we'll need to delete it and then set it with this new value. That's pretty straightforward. It's just ensuring that we have a unique item in the map. The tricky part now is, what do we do if the cache size is already up to its capacity and we need to delete the oldest item as well? If the cache doesn't already have that key, the next thing we'll want to check is if the cache size is equal to the capacity, in which case we'll want to delete the oldest item from the map. And that takes care of our implementation. We can now instantiate a new object with the new keyword and give it a capacity, and then start calling its methods like putItem and getItem. But how do we know our code is actually working as intended? We could play around with it until we're confident, but that's not very efficient. In the next video, we'll look at test-driven development and how to automate the testing of our code with vtest.